Eppur Si Muove. It's an Italian phrase, one that kind of whispers to us from history, and it perfectly captures this really surprising idea that art and technology aren't these two separate worlds we imagine them to be. Actually, they're deeply, powerfully connected. So let's dive in and see why.
So what does it mean? Well, it translates to, and yet it turns. It's the statement of a persistent, observable truth, even when everyone else believes something different. And the whole point of this exhibition is that both art and science are driven by that same fundamental impulse, to look at the world and show us something completely new about it.
And this is the guy famously tied to that phrase, Galileo Galilei. The legend is that he muttered these words right after he was forced to recant his theory that the Earth revolves around the sun. It's this quiet, defiant statement of scientific truth, and honestly, it sets the stage for everything we're about to explore.
You know, we're so often taught to put art and science in these separate boxes, right? Art is all subjective and intuitive. Science is objective and all about the facts. It feels like a really clean, simple division. But this entire idea, the one we're digging into today, it just throws that whole concept out the window. It proposes that these two fields actually live and breathe in a shared sphere, a place where curiosity, creativity, experimentation, and even intuition are the things that really matter. So, our first stop on this journey is about something really basic, the act of measurement. This is all about the incredible quest to take the invisible forces that shape our entire universe and somehow make them visible. I mean, just think about it for a second. For centuries, the idea that the Earth rotates was just that. An idea, a theory. How could you possibly prove it in a way that a person could just stand there and see it happen with their own two eyes? Well, the answer turned out to be this absolutely brilliant and elegant device. In 1851, a man named Leon Foucault built a pendulum, and as it swung, the floor underneath it slowly but surely rotated. It was the first real tangible proof of the Earth's spin, and it's a scientific instrument that just happens to be breathtakingly beautiful. And get this. This was the actual invitation sent out for the big public demonstration. Can you just imagine the excitement? This wasn't some boring lecture. It was a live performance of how the cosmos works. You are invited to come and see the Earth turn. I mean, come on, that is absolutely brilliant.
Now, that same drive to visualize the unseen, it carries right over into geometry. We've always used abstract shapes to try and get a handle on reality, all the way back to Plato's solids, which people literally thought were the blueprints for the universe. Or think about descriptive geometry, which is the whole basis for modern engineering that lets us draw 3D objects on a flat plane.
And this connection is not new. It goes back centuries. Just look here. On the left, that's a teaching model from the 1800s, built just to explain complex geometric surfaces. On the right, that's a kinetic sculpture from the 21st century. They look so different, but they share the exact same DNA, a total obsession with form, with motion, and with the hidden rules of space. And what about measuring the most abstract thing of all, time? That has been a relentless, centuries-long quest for precision. From Galileo's first ideas about pendulums to Huygens making them more accurate, we eventually see the second become a standard unit. And that process is still going on today, as we just keep slicing time into tinier and tinier little pieces. Okay, the next chapter in our story is all about revealing the unseen. And in this part, both artists and scientists are kind of like lens makers. They're building the tools that help us see things that are way, way beyond the limits of our own senses. The reality that we can perceive is just this tiny, tiny sliver of what's actually out there. You've got the infinitely large world of stars and galaxies above us, and the infinitely small world of particles and nanotechnology below us. And it turns out, both art and science are completely obsessed with exploring these two extremes.
Now, this is not just a beautiful painting. This is a scientific document. It's a drawing from 1881 capturing an aurora. See, before photography was good enough to capture things like this, science had to rely on the artist's hand to literally see the cosmos.
And if you jump forward to our century, the exact same principle is at work. These incredible drawings are inspired by the little traces that subatomic particles leave behind in a bubble chamber. The artist is translating the visual language of physics into art, showing us the hidden dance of the infinitely small. So, a huge breakthrough in the 19th century was the realization that light behaves like a wave.
this totally unlocked a new way of understanding color, interference, and perception, concepts that are just as critical to a painter as they are to a physicist. And this right here just illustrates that intersection perfectly. This looks like a piece of 20th century abstract art, doesn't it? Well, guess what? It's a painting from 1882, and it was created for one purpose only, to teach physics students about light interference. It's a work of science that looks like art, decades before abstract art was even a thing. It's just amazing.
So, all of this naturally leads us to our third section, inventing new realities. This is where that shared curiosity gets applied. It moves beyond just discovery and into actually shaping the world all around us.
And there's a pattern that you see happen again and again. It starts with a scientific discovery, like, say, understanding how sound waves work. That leads to an invention, like the telephone. That invention gets integrated into our society, and then the artists come in to reflect on it, to critique it, and to reinterpret what this new technology really means for us as people. Just take electricity. The scientific investigation into this invisible force didn't just lead to a massive technological revolution, it also gave artists completely new mediums to play with, from neon lights all the way to digital art. You see, both fields are harnessing the unseen to create something real and tangible. And finally, this brings us all the way back to our main idea, the shared sphere. What this whole exploration really shows us is that the boundary we think exists between art and science, it isn't a solid wall at all. It's porous. People are crossing it constantly. And this really ties it all together. We've seen that technical objects, like Foucault's pendulum, have this undeniable beauty and are born from real intuition. At the same time, making art often involves rigorous research and intense experimentation, just like science. The old, easy distinctions just completely fall apart. And maybe nothing embodies this idea more than this piece right here. It's called Prototype for a Non-Functional Satellite. It is a sculpture, but it's built using aerospace engineering, and it is designed to go into orbit. So, is it art, or is it technology? Well, the answer, of course, is that it's both. It exists perfectly in that shared sphere. So, this whole journey through the worlds of art and science leaves us with one last big question. As these fields keep converging, blending aesthetics with engineering, data with design, where will our shared, relentless curiosity take us next?